Hi friends, this is Bhavani. Today my presentation topic is N-type MOSFET. Here the agenda of N-type MOSFET are mass capacitor, accumulation, depletion mode, inversion, and N-type MOSFET construction and working. Here this structure is known as mass capacitor. What is mass? Mass means metal oxide semiconductor capacitor. Um, Here, the structures look like a parallel plate capacitor, where one of the plates in the semiconductor and other is the edge, other is the gate metallization. The insulator between the parallel plate is the oxide. This is the um, silicon dioxide. Here, the metal is contains electrons, and here I am taking the p-type substrate. In p-type substrate, majority charge carriers are electrons, and minority carrier charges are uh, electrons. Majority carriers are holes. This structure commonly referred to the two-terminal device and with one electrode to the metal and other electrode connected to the semiconductor, and voltages depends on the capacitance result. Here, in mass capacitance, here I am applying the negative voltage to the metal and positive to the mass p-type substrate. Uh, here, the negative voltage is connected to the metal. In metal, in electrons are there, so the negative are repel each other. And here also the positive. Here the holes also positive. So then positive repel each other. The both metal and p-type substrates are repel to each other. So then here electrons and holes are accumulating together. That means they are coming towards to the SiO2 layer. So this process is called as a accumulation and depletion mode. This is I'm giving the positive voltage to the mass capacitor here, and the positive to the metal and negative to the p-type semiconductor here. The positive given to the metal, the electrons are attract with electrons are attracted with the positive, so they are attract with each other. Here also negative and positive they are attracted with each other in p-type semiconductor. So here the depletion layer is formed. This is the inversion mode. Here I am applying only positive voltage. Here also I am applying positive voltage, but I am applying greater than threshold voltage. Then same it's look like a parallel plate capacitor. Okay, um, I'm giving to positive giving to the metal. Then here already electrons are there. I'm giving the higher threshold voltage, higher than greater than threshold voltage. Then here the metals are um, 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 down to the SiO2 layer, goes down to the SiO2 layer. So the metals are placed in the semi p-type semiconductor. This process is called as a inversion mode and n-type semiconductor. This is the N-type semiconductor. Why? Here I am taking P-type substrate. I am doping N plus. I am doping N plus. Uh, okay, here I am taking here P-type substrate. Here I am doping uh, uh, N plus channels. Okay. Um, First of all, we know that was MOSFET. What is the full form of MOSFET? MOSFET is metal oxide semiconductor field effect transistor. Is commonly known as MOSFET. In a electronic device, is used as a switch and amplifying voltage in circuits. Okay, it is act as a switch. Okay, it is a voltage control device. The MOSFET is also voltage control device, and it is connected and it is constructed by the three terminals. One is gate, and second one is source, and third one is drain. Okay, the MOSFETs are actually two types. One is N-type MOSFET, and second one is MOSFET. Here I am only discussing about N-type MOSFET. Mm, Here we take p-type semiconductor. we can add two N-type semiconductors on two sides. Here one is drain and other one is source side, and in this we have the three terminals, gate and drain and source. These three terminals are voltage controlled devices. Okay, in above p-type semiconductor, we have a thin thin layer. Here we have a thin layer. This is the SiO2 layer. In p-type semiconductor, majority carriers are holes, and n-type semiconductor, majority carriers are electrons, and minority carriers are holes. When electrons and holes are mixed place, when electrons and holes are mixed with each other, and the place is known as depletion layer. There the depletion layer is formed. Here I'm applying some voltage to the drain to source. I'm applying negative voltage to the source and positive voltage to the drain. Negative voltage are going to the source terminal and negative are repelled with electrons, and they are repelled with each other. Then the electrons are moved into p-type. The electrons are moved here. The electrons are moved into p-type semiconductor. Then depletion layer decreases, and it helps to current flows. Here the some current is there. So it helps to current will pass. And another end, I'm applying the positive to the drain terminal. So the positive is attract with electrons. Then depletion layer of the drain will increase. Okay, here I'm on decrease. I mean, here the depletion layer of drain will increase, and it will stops the flow of current. Okay, here the here it will allows the flow of current, but here in drain side it stops the flow of current. uh, uh, and similarly, here I'm applying positive voltage. I means Vn greater than Vth. Positive voltage I'm giving to the positive voltage to the gate terminal. um, the metal will attract the positive voltage. Okay, and in metal contains electrons, and p-type minority charge carriers or electrons are attracting each other. Okay, sorry, majority carriers are holes, so the electrons and holes are attracting each other. Then the result depletion layer is decreased, and the flow of current is formed. Keep the gate, we apply certain voltage, then the flow of current is formed. Here Vn greater than Vth. Okay, greater than Vth voltage, then the flow of current is the current will flow. For example, we take the Vn greater than Vth voltage. Here there is no flow of current. Okay, totally this type of N-type MOSFET. It is act as a switch. Okay, that it is act as a switch, and it is a transistor. Okay, thank you.